All right, here it is. Here's the prompt. I have 5 over 4, 5/4, plus 3y over 2 equals to 7y over 6. I want to solve for y. Notice that this time it's no longer an expression. This is an equation involving fractions, right? Any strategy on how to solve this? Huh? Ah, why would you do that? Very good. Yeah. Yes, we remember. That you remember I taught you this in the past, but the way to clear a fraction, we can clear a fraction, can't we?
Yeah.
We clear a fraction by multiplying every single fraction by what?
LCD.
By its LCD. That's it. So look at the 4, 2, and 6 here and tell me, what is the LCD for 4, 2, and 6?
12.
12. All right, so that means if I take that 12 and multiply to every single fraction, that's the trick for this whole lesson, is to find the LCD and then multiply it into every single term to clear the fraction. Because we do not want to deal with fractions at all for this kind of problem. What do we want to do here? You want to multiply 12 times 5
No.
to get 16 divided by 4? Or you like to cross cancel first, then multiply? Well, let's cross cancel. 12 cross cancel with the 4. 3 times 5? 15. That's a lot easier, right? For those who still like to multiply, yeah, 12 times 5 is 60. 60 divided by 4, still 15. It's still, you get the exact answer. But you don't want to multiply first because you will get a bigger value. Sometimes it's harder for you to keep track of bigger values. So always cancel, then multiply. Over here, what do you get? 6.
Divided by 3 is 3y.
2.
You're not dividing. You already cancel. That means you already divide. What's the last step after you divide? You multiply, right? So what do you have? 18y? Do you know how I got 18y?
Yeah, 6 times 3.
12 divided by 2, 6. 6 times 3y, 18y. Over here, 12 divided by 6 is 2. 2 times 7y,
14.
14y. All right. It's a regular equation. How do I solve for y? What do you do? Subtract 18y. Very good. You want to move all the y's to one side. Remember, isolation. Want to solve for the single variable. So I'm going to go ahead and move the 18y. You can certainly do something like this to remind you about moving all the boxes to one side, circles to one side, whatever. But I want to move the box over, 18y. I have to do what? Subtract it. Okay, opposite of operation if I want to move the entire content of that object, right? So you minus the 18y over. What is 14y minus 18y?
Negative 4y.
Negative 4y equals 215 and divide. Very good. So notice this time I'm not moving the entire content. I'm just removing this negative 4. So to do that, I look at what's linking the negative 4 to y. It's linked by a multiplication. So therefore I perform the opposite of that, which means dividing. And so y just simply 15 over negative 4. Question on that problem. Is it easy enough? Okay. If it's easy enough, go ahead and try this problem on your own. There. Go. Okay, so take a look here. Of course, you all found 70 to be your LCD, right? So we're going to go ahead and take that 70 and times it to every single term. Here's 70 and 70. If you are not comfortable with cross-canceling, don't do it. Just multiply and divide at the end if you want. But I told you that I did warn you about getting bigger values. Like, for example, I don't think you're going to like taking 27 times 70 divided by, well, it's easy for that one, but it's up to you. I don't really mind if you want to do it that way. But the other choice that you could have done is just go ahead and cross-cancel. 70 divided by 7 is? 10 times 2x?
20x.
20x. See? It's a lot simpler, right? And over here, 70 divided by 10? 7 times 27. 189. And of course, last one here, 70 divided by 5 will get you 14 times 4x. 56x. See it? Now what do you do? Which one do you want to move? 20x, okay. Because you already have this x on this side by itself. So subtract the 20x over. You get yourself 189 equals to 36x. Now what? Divide. So you got 36 both sides here. And so x is simply 189 over 36. Now, if you want to divide, get back to decimal, yeah, sure. But hey, we want to leave it as a fraction and we want to simplify it. Can we simplify 189 over 36?
Yes.
By what?
3.
By 9, okay, sure. But for those of you who didn't see, oh yeah, 9 right away, just do 3. That's fine. You are not in a rush to get it to 9, okay? I don't want you to do something you're not sure about. But let's just say that you do it one step at a time. Divided by 3, you got 63 on top and what? 12 on the bottom? And then from there, you can divide by 3 again. That will give you what? 21 over 4. So if you divide by 9 right away, you will get the same answer, 21 over 4. And that is your simplified fraction. Is that easy enough? Okay. All right, so far we have numbers in the denominators. Looks easy to find the denominator, LCD. What if I have a problem that involves variable? So let's start small this time. What if just this? What if I have just x on the bottom? What is my LCD for this one?
X squared.
X squared or x?
Oh, X.
Huh. Do you see that? If you were to do the ladder on it, what can you take outside? Just x, right? And the leftover is just 1. So it's x times 1 is just x. And so x is, what do you be multiplying to each one? Is that correct? Is it? Once you have your LCD, that's what you do. Multiply to every single term. And look at the first term. What does this x do to this x down here? Cancel out and out. So it's cancel each other out. What do you have left? Just 3x plus 2, right? What about that one? Just x plus 3, right? It cancel each other out. And on the right-hand side, 5x. And look. Looks very complicated at first, is that correct? But once you have the LCD taken care of, and the fractions just kind of disappear, and this is what you have. What do you use from here? What I'm seeing is I have x's on this side, I have numbers here too. What can I do? Combine like terms. Yeah, let's combine them first before moving. Since they're already on the same side, right? Let's combine like terms. Look, I have the x here to combine. I have the boxes to combine. If they are on the same side, just put them together. What is 3x plus x? 4x. What is 2 plus 3? 5. Of course, I have 5x over here. Now, what can I move? The 4x. So I subtract it over both sides. I have 5 equals to what? 1x, and you know 1x is x, right? So therefore x is 5. That's it. And then of course, don't forget that you can always plug it back into your problem to see if x works out. And for this particular case, it works out perfectly. Okay. Is that good so far? Okay. Now, this is a case where we have not just a monomial on the bottom. We have, like we're talking about multiple terms, a binomial. And I want you to find the LCD. We just reviewed how to find the LCD, right? So look at this problem right here, and can anyone tell me what is the LCD for this equation? There you go. You're right. It is. Because if you look carefully enough, this is over 1, right? So if it's a 1, we don't really care. Is this completely factored?
Yeah.
Okay, so let's parenthesize that. Is 8 plus 2 completely factored?
Yeah.
It is also, and then now you just compare. Do I have anything common to take out? Nothing. So basically whatever's left in there is my LCD. So I multiply the entire thing with what?
8 minus 3 parentheses 8 plus.
There you go. So my LCD, I'm just going to go and write it on the side here, is a minus 3, a plus 2. That will get multiplied to every single term. Is that true? Now, because it's a bit long, I can't squeeze it in here, but you can kind of see what's happening here. If I multiply this to the first term, what will get canceled out? If a minus 3 gets canceled out, what's left over?
8 plus 2.
So what will happen to the leftover? What do you do with that? Just like the before. What did you do after you cancel? Yeah, you multiply. Whatever you have left, you multiply to the top, right? Just like this one right here. Remember this right here? Let's say 3, and if this is 6, after you cancel out, you have 2 left, right? then you multiply that 2 to the top. Same thing here. Instead of having just like one number, it's a multiple terms, but it's the same exact concept. So notice that after I cross out a minus 3, I still have a plus 2 on left over. So I take a plus 2 times it to the top. So now on the top, it looks like the following. Any question on that for the first term? Look at the second one. Anything get canceled out?
Yeah.
Anything at all? Not really, nothing, right? There's nothing common for me to cross out, so what gets multiplied to the top?
A minus 3 times A plus 2.
Yeah, everything. So now the 2 still remain, but in place of that, I also have a minus 3, a plus 2 get multiplied to the top. Now look at the last term. What get canceled?
A plus
A
2.
plus 2.
What gets multiplied to the top?
A minus 3.
A minus 3. So I have 12, a minus 3. Okay. Okay, you see that so far? Now, when you get to this case right here, and our goal is to solve for a, right? You have a whole bunch of a. They all got tied up inside parentheses. Cannot break them loose yet. So the only way is to free all the a's. How do you free it? Look at this. This is a binomial times a binomial. How do you free it out? It's a binomial times a binomial. So what do you do with that? Box it, right? So every time you see it like that, box it. Box it, and what do you do here? Distribute. See it? So you got to use the right strategy to free out your a. If it's inside parentheses, you cannot do anything about it yet until you free it. And so let's do the box on this first thing. You put it outside or inside?
Outside.
Outside. So a plus 2, 2a minus 3. And when you multiply it, I'm just going to go and do it quickly for you here. 2a squared,
4A.
4a,
Negative
negative
3A.
3a, and negative 6. And I'm going to do this same box over here too. I have a minus 3, I have a plus 2,
A squared.
a squared minus 3a, 2a, and negative 6. And I'm going to distribute this as well. I have 12a minus 36. You see it? So I try to clean up as much as I can. Now I put the whole thing together to show you here. And that's simply going to become 2a squared plus 1a minus 6. And over here I have negative, maybe I'll use a different color to show you. Negative 2, and the inside of the box here is a squared minus a minus 6. And over here is equal to 12a minus 36. You see it? 3 different parts, and that's what I just did. Okay? And here though, because there's a negative 2 outside, what do I do with that? What do I do with the negative 2? Distribute that as well. So the entire problem now looks like this. It looks very intimidating, I have to agree with you. But once I write everything out, it'll look a bit better. Plus 12 equals to 12a minus 36. There you go. Do we see like terms?
Yeah.
Bunch of them, right?
Yeah.
So let's take a look at a few. You got 2a squared and negative 2a squared. Oh, wait, they're opposite. What do you do?
Cancel out.
They cancel out already. Done. You have, yes, go ahead. I have a 2a squared and this is minus 2a squared. They get canceled, right? And here's an a, here's an 2a. What is that?
2A.
Or 3A.
3a. We're combining like terms. Don't forget, we're not multiplying, we're combining. We just put them together. There's 1a, it's 2a, that's 3a. What about negative 6 and positive 12? Plus 6. And on this side, it's just 12a minus 36. Look at that. Now it looks a bit better, even more. So how do I solve for a? Move what over?
3A.
Let's move the 3a, sure. If you move the 3a, I'm going to subtract it. I end up with 6 equals to 9a minus 36. Now what do I move over?
Negative 36.
Okay, so how do I do that? Add it. Okay, so I add 36 over. It becomes 9a equals to 42, right? Now what?
Divided.
Divided by 9. Okay. Lots of work. And can we reduce 42 over 9? What can you divide both by? By 3. If you divide both by 3, what do you have? Well, at the bottom is 3 for sure. What about the top? 14? Right?
Yeah.
Okay. There you have it. So, it is one long problem. but it's not something that's not out of reach. Starting from the very top, find the LCD, get rid of the fractions, bring out the a by multiplying using boxes or distributive, combine like terms, move everything over, But notice that the important thing is, because it's an equation, we have to solve for the variable. That's just the bottom line. And if you see at the end here, all that we have left is just a. Therefore, we can just isolate the a, bring it all over to one side, bring the number to the other side, and solve for a at the end. I want to go ahead and show you this last problem right here that involves something that's a bit strange. Okay, so take a look at this. But first and foremost, just like always, what is the LCD? Look carefully. This is multiple terms, so you gotta have a good look at it before you say, yeah, this is my LCD.
X plus 3.
What is the LCD? Or at least you describe to me what steps you're gonna take to get it prepped.
Everything factor.
X squared.
Factor. See, the first thing you should do, like I said, and you have heard it before, is start looking at each case to see if it's completely factored. Put parentheses around it to indicate that it's done factoring. But for the case of x squared plus 3x, is it completely factored?
No.
No. How do you factor that out?
Take out an X.
Take out an x. So let me rewrite the problem to show you. If I take out an x, what do you have left inside?
X plus 3.
X plus 3. And over here, I have x plus 3 as well, and this is just 1 over x. Now I look at all three terms and ask, what is the GCF? I'm sorry, what is the LCD?
X squared times X plus 3.
X outside and X plus 3.
Okay, well let's do it one step at a time then. Look at this carefully. If you're going to do a ladder on this thing, oh wait, actually, when you do a ladder, especially with this kind of problem, it's a point just do 2 at a time instead of doing all 3. Just take a look at the left-hand side. Do one side first. What is it in common you can actually take out?
X plus 3.
X plus 3. If you take x plus 3 out, what do you have left over?
X.
X and
1.
1. So now you know that you're going to take the outside, multiply the inside, right? So isn't your LCD on this, just the left-hand side, x times x plus 3? Now you bring down the right-hand side, which is x, and do a ladder on it again. What can you take outside?
Nothing.
X.
X.
The x. You take outside the x, what do you have left over? X plus 3 and 1. And you do the same thing again. X times x plus 3 times 1, which is x times x plus 3. So that means my LCD for the whole thing is
X times X plus 3.
x times x times x plus 3. And don't forget the technique. Just do one side first before you bring the other side to the ladder. Okay? So at least we know that x plus 3 times x is our LCD. Let's write it on the side here. Oops. Here we go. There. If I'm going to be multiplying to every single term, let's take a look to see what we can cancel out. Look at the first one. What can we say?
Cancels out.
Everything. So that means the top will be what? Just 3. Good. There it is. What about the second term?
X.
Okay, so what will get multiplied to the top?
X.
Just x. What about the last term?
X plus 3.
X plus
Uh-huh. X plus 3 times 1, right?
Yeah.
But you know x plus 3 times 1 is just itself, so we don't have to write it. But there it is. You start with a very complex. Got the LCD, cancel out the fractions, and that's what we got. So what do we do here? Distribute it, okay. So we got 3 plus x squared plus what? 2x equals to x plus 3, right? Okay. What's different from, what looks different from here is this. Let's go ahead and combine like terms as much as we can. Do we have like terms?
No. Oh, 3.
Okay, let's move the 3. So subtract the 3, right? What else? We got x squared plus 2x left equals to x, because the 3 got canceled. Now what?
Squared.
Anything else that in common that you want to combine? The x. Where do you move the x?
2x.
Now, see the
2x.
see the trick question now is, wait, am I going to move that x to the left or am I going to move 2x to the right?
2x.
What is it that we want to happen?
All variables on one side.
Very good. All the variables on one side. So how do I move this x over?
That's right.
So you got x squared plus x equals to?
0.
Oh, wait, what does that remind you of? What is that, 0 on one side?
Property.
Zero product property. That's what we want. When we have multiple variables involved, especially with the powers that's bigger than 1, we want it all on one side and 0 on the other side because we want to use Z2P to solve it. Okay? Now look at this carefully. Can we do something with x squared plus x? Can we factor it?
No.
Are you sure? When I say factoring, the first thing you should start asking is it in order? Is there a GCF? See it? I never talk about dots yet. You still have those basic questions to ask. What can you take outside? X. So if you take the x out, what do you don't, well, basically this is all you have left, right? See it? How many cases do you have here? 2 cases. What is the answer here for the first case?
Negative x.
How do we solve for 0 again?
Or negative x.
How do we solve for 0? How many cases do we have? 2. How do you solve for 0? You said each case equals to 0. So the first case is x equals to 0. So meaning x is 0 because there's nothing to solve anymore. Second case, x plus 1 equals 0. So what is x? Negative 1. So I have 2 solutions, right? But do not be happy yet because here's a big problem. Remember we talked about excluded values before? What are excluded values?
What? The product cannot be.
What cannot be 0? The denominator. So let's go back here. Go back to the problem, beginning problem. We got 2 solutions. Negative 1. If we plug negative 1 back into x in the bottom, any chance of those turning to 0 ever?
Yeah. No.
Look at it. If we take negative 1 and plug it back into x here at the bottom, will it ever become 0?
Yes. No.
Well, look at it. If you plug in a solve for each case, will it become 0 at all? If you take negative 1 and plug it into x. In this case, this is negative 1 squared, which is a positive 1. 1 plus a negative 3, that's not going to give you 0. Over here, negative 1 plus 3, not going to give you 0. And negative 1 would never be a 0. But look here, though. If x is 0, yeah, you can say the first 2 terms won't give you 0, but look at the last one. If x is 0, 1 over 0 is? 1 over 0 is? 1 over 0. Have we talked about having a 0 in the bottom already? That cannot be allowed because we will get what back as an answer? Undefined answers. So I want to make something clear here. Before when we find excluded values, it was just an expression. No equal signs, right? We call those excluded values. Now when we solve for an equation, and our solution here happens to make it undefined when we plug it back in, we do not call it excluded values anymore. Instead, we have another term for it. We call that, here we go, extraneous solution. Extraneous, meaning it's like excluded. It won't work if you plug it back in, and you can see why now, because if you take 0 and plug it back right there, 1 over 0 is undefined. It'll make the entire problem invalid. Okay, so please remember that if you got answers at the end here, always test it. Is it one of your excluded values? If it is, do not write it as a solution. Instead, label it as an extraneous value or extraneous solution. Okay? Is that clear? I mean, you got to make sure you test it, guys. Okay? All right. Here we go.